Hello and welcome. Today I decided to respond to your request that the naming of organic compound and IUPAC nomenclature should be taught in the full lesson. So the purpose of this is that at the end of this lesson, you should be able to name and as well as draw organic compounds, as many of them as possible. So let's see, just follow me. I'm going to start from simple to complex. From simple to complex. If you are good at this, in the beginning you say, these are the ones I know. But towards the end, you see some new ones, some new things that you don't know, or some new things, the rules that you have not observed. So please follow us from the beginning to the end. Thank you very much. So I would like us to take it from the beginning. So let's start with the aliphatics. The aliphatics, which are the hydrocarbons. The hydrocarbons. I don't want to go to the aromatic, that is the benzene. So let's go to the hydrocarbons. That is the alkenes, and what? Alkynes. So hydrocarbons, organic compounds that contain hydrogen and carbon only. Hydrogen and carbon only. So the alkanes have single bond, alkenes double bond, alkynes triple bond. Now, alkanes are represented by the formula CnH2n plus 2. Alkenes CnH2n. Alkynes CnH2n minus 2. Now observe this: plus 2, 2 minus 2. Now what is N? N represents carbon atom number. So let me put it here. I've taught this before and I'm repeating it. Carbon atom number 1. One carbon atom is what? Met. 2 carbon atoms is what? Earth. Many of you know it, but let's just assume you don't know it. 3 carbon atoms is what? Prop. 4 is what? But. 5 is what? Pent. Let me clean this place. Please permit us. 6 is what? Hex. 7 is what? Hex. 8 is what? Oct. 9 is what? 2n minus 2. 9 is what? None. And 10 is what? Decagon, decane, and all these ones. So please manage to observe it like this here. So we are managing our board, please. So and the rest of them, it can continue octadecyl, octadecanate, and all those ones. So we can continue with them. These are the basic ones I want us to use for now. Alright. Now look at all these ones. So one carbon atom is 1. So alkanes have single bond. So if we have, the first one is methane. Methane. C1. H. So you don't write the 1. 2 times 1. 2 plus 2. 4. Methane. This is what we call molecular formula. So let's give you the structural formula. 1, 2, 3, 4. At the end of this, we'll look at this place. At the end of this, we'll be able to name all these, as well as be able to draw other ones. At the end of this, you should be able to name all these, as well as draw other ones. Please. Alright, thank you for doing that. Okay, let's continue like this now. So this is methane. H4 like this. Okay, this is H4. This like this. Now we can go to the next one. We can go to the next one. Permit me to clean the board. I'll be cleaning the board and I'll be giving you. This is methane. You can do the next. Take the next one. Earth is C2. I'll only be doing 3 for each of them. C2 H 2 times 2 4 plus 2 6. Methane. So you draw like this. 1 2. Link it all through like this. H and H. Methane. You can condense it. If you want to condense this is CH3. This is condensed. This is expanded one. Alright. So we can clean this one, and you can do propane. That is C3. I said we end it C3 H 2 times 3 6 plus 2 8. 1 2 3. You link it. You link all of them. Alright, so that's how this one applies. Okay, so we'll move to the next one. We move to the next one. We have touched the alkanes now, but we are still going to come to something like this that will have triple bond, single bond. This one has single bond all through. So we are still coming to something like this, but I just decided to take it from simple to complex so that you'll be able to draw and name anything at all. Alright, so we have taken care of the alkanes. We move to the alkenes now. Let me clean this place and clean out so that we can keep having space. Alright, so now look at this. The alkenes. So the first one, we don't have methane. The first one is ethene. Remember, we don't have methane. The first member of this is ethene. We are still going to do it in organic chemistry. Alright, do all the preparation, the properties, the reactions, addition, reaction, and all that things that they undergo. We are still going to do all these ones, but now we are focusing on the naming of organic compounds. So we are, as I said, from simple to complex, we are going to do the very, very, very hard ones. Watch out. So the alkenes is what? Cn H2n, Cn H2n. So ethene, H2, C2, C2H, 2 times 2, 4. So now double bond. Watch. C, double bond C, 4. 1, 2, 3, 4. It is obtained from the parent alkane. If it is the alkane, look at it. Single bond, 4 like this. So when you in it, when you put any single bond, like any additional bond, 2 hydrogen atoms have to go. In case if, okay, let me say, let's add another bond to enter ion. If I put another bond here, I will delete 2 hydrogen atoms like this. So that we are still at 18. So the first one, I repeat, see the alkane here. This is methane. So methane, double bond, we clean these two. So H, 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 H. Methane. So the next one we can have is prop 1 in. Prop. That is prop is what? C3. So say C3, H, 3 times 2, 6. Propene. 1, 2, 3. This is the parent alkane. Alkane. So 1 in, you in it. So you know that when it is like this, look at it. This is propane. In. You can clean here, remove these two. Then you put hydrogen. Did you get it now? When you add any bond, you remove 2 hydrogen atoms. Very simple. This is 1 in. 1 in. Propene. That is prop 1 in. 1 in. 1 in. So we number it from here. 1, 2, 3. This is not just like this. So we are still going to do the numbering. They said you must number from right to left. It's not always true. Some people will say, number from right to left. It's not always true. It is conditional. As we are going to see it in this, we are going to look at this and observe some things there. All right. So this is prop 1 in. So we can go to boot 2 in, boot 2 in, or boot 1 in. Now look at this one. Boot is C4. H2 times 4 is what? 8. So we'll draw it 1, 2, 3, 4. Always take note of the parent alkane. Start with alkane. Then boot 1 in. 1 in. You know that normally you put hydrogen here as usual. So 1 in. If you put it here, you remove this and remove this. So you can have H, 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 H. Boot 1 in. Boot 1 in. If it is boot 2 in, look at 1, 2. 1, 2, 2 in. So if you have added a single bond here, you have to remove 2 hydrogen atoms. Boot 2 in. This one is boot 2 in. So we move to the alkyne. We move to the alkyne. Move to the alkyne. Move to the alkyne, which is the 3 bonded hydrocarbons. Hydrocarbons with 3 bonds. Alright? Let's go like that. Alright? So let's clean this place to avoid confusion. We have alkynes now. The ones with 3 bonds. Alright, let's go. Triple bond. Alright, let's go. So there's no ethyne. We have methyne. We don't have methyne. We have ethyne. Sorry. Start with ethyne. Ethyne. C2 H 2 times 2, 4. 4 minus 2, 2. So this is ethyne. 2 times 2, CnH2n 2 times 2 for 4 minus 2 is 2. So we have 1, 2. This is from the parent alkane I told you. Then you have hydrogen, 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 hydrogen. When you bond it to make it double bond, you clean these two. When you put another one, you clean these two. So this is what? Ethyne. C2H2, ethyne. Ethyne. So if we have prop 1 ine, so you have 1, 2, prop 3. 1, 2, 3. 1. You know that this is normal alkane, right? Normal propane, propene, propine. So hydrogen, 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 hydrogen. This is prop 1 ine. Prop 1 ine. See it here. So you can draw but 1 ine, but 2 ine, pent. 1 ine, pent, 2 ine. I hope you can get that. Or hept 3 ine. You can do all those ones. Just from the propane, draw it straight, count, add it and remove it. You can get it. It's not difficult. So now, let's now come to the naming of these hydrocarbons. These ones do not have functional groups. They have only substituents. This is methyl, this is alkyl. And when you have alkyl or alkyl, as some of us may pronounce it. Alright, so when you have alkyl, you have something like this. You have something like this. This one is formed by what? Loss of hydrogen atom. Hydrogen. Loss of hydrogen. Now this is from methane. Methane. If it forms from methyl, it forms CH3. This is called what? Methyl. So it has lost one hydrogen atom. Methyl, it has lost one hydrogen atom. From methane to methyl. Alright? So, see. So anything like this is methyl. Now let's look at naming of these hydrocarbons. Let's look at naming of these hydrocarbons. Let me start with this, the rule. If you look at this, you can identify this. Ine, in, because it has triple bond, the name will end in ine. This one has double bond, the name will end in in. This one does not have any single or double bond, so you have it in. That's the first thing. Now look at this. Let's start with this one. Let's start with this one. Look at it. If you have substituents that are like, pay attention now, elements. See this element. Have the halogens bromine, chlorine, methane, methyl. So now, what you are going to do now is to observe, to count, to look for the side. The first thing to identify while naming or drawing is what? What we call what? Come this way. The longest carbon chain. That is what I want to show you now. Very, 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 very necessary. You have something like that in this diagram. You have something like that here. You have something like that here. You have something like that here. But the one that will give you the typical longest carbon chain is this. Many students, many people will look at this as the longest carbon chain. 1, 2, 3, 4, 5. It is not. This is more than 5. The longest carbon chain is the longest straight. It continues, whether it branches. So this one has the longest chain is 1, 2, 3, 4, 5, 6. 6. 6. There are 6 of them here. So 6. 1, 2, 3, 4, 5, 6. Not 1, 2, 3, 4, 5. Because it continues in this form. But if you happen to have something like this, sorry for this. If you happen to have something like this, CH2, CH3. So it means that this is the longest carbon chain like this. 1, 2, 3, 4, 5, 6, 7. I hope you can get that now. So what we have here is what? CH, this is H now. So 1, 2, 3, 4, 5, 6. Okay, so we are going, let's start with this one that is alkane. So the longest carbon chain is 1, 2, 3, 4, 5, 6. It's better to count it like this because this one is equal to this one in number 1. So now the problem is, where do we start numbering from? The first thing you check is which substituent is closer. Here, this is methyl, you count 1. Here, this is chloro, you count 1. So it is like, it is balanced. When it is balanced, this is an attachment. Let me call it an attachment. These are also attachments. It is balanced. When it is balanced, you start numbering from right to left. But let me just assume that, we have something like this. CH3 like this. Watch. We have 1, 2, 3. The number 3 is carrying a substituent, an attachment. Now 1, 2. This one is carrying a methyl. We'll number from here. 1, 2, 3, 4, 5, 6. I'm very, very sure of this. So you number from here like this. But in this situation, you have something like this. In that situation, in the original situation, we have something like this. Chlorine, chlorine. So we have to number, because 1 before this. Unlike the other one, it was here, number 3. Here, 2. So the side that is closer. So we have 1, 2, 3, 4, 5, 6. So you now determine the one that is carrying what. So now, number 1, number 2. Number 2 carbon atom is carrying 2 chlorine atoms. Number 3 is carrying 1 bromine. And number 5 is carrying what? Methyl. Now we are going to name it. 2 means di. 3 means tri. 4 means tetra. 5 means penta, and so on. Look at this. When you look at this, you see that you have chlorine and bromine. So we are going to arrange this in alphabetical order. Bromine, chlorine, methyl, PCM. So we start with this one. So it's 3 bromo, 2 dichloro, 2 dichloro, 5 methyl, 1, 2, 3, 4, 5, 6. Hexane. Hexane, 6 hex, 7 hex. So 3 bromo, 2 dichloro, 5 methyl hexane. That is this. 3 bromo, 2 dichloro, 5 methyl hexane. Now let's do something like this. Watch. Can you draw something like this? 4 bromo, 2, 3 dichloro, heptane. So if you ask to draw something like this, the first thing you watch, hept. You now start with hept 7. 1, 2, 3, 4, 5, 6, 7. So if you are numbering it from right to left, it will be easier for you. So you can say 1, 2, 3, 4, 5, 6, 7. So your number 4 is carrying bromo. You can put it here. You put it here. Br. 2, 3 dichloro. So 2 will carry chloro. 3 will carry chloro. You can put it up or up down. So 2, 3 dichloro. Heptane. Have you seen I first of all look at heptane. 7. Then 4 bromide. Number 4 bromo. 2, 3 dichloro. Number 2, number 3. It's not difficult. So you can now link them with hydrogen atoms. Let these numbers be clean now. You only use these numbers to identify carbon atoms carrying them. Alright. So this is how this one is. So if Waec asks you to do something like this, you can do it. It's not difficult. 1, 2, 3, 4 bromo, 2, 3 dichloro, heptane. It's very simple now. So this is for the what? The hydrocarbons. We have not even entered the ones that have functional groups. Not entered the ones that have functional groups. Okay. We now proceed. So we have taken note of this. Now let's clean this one now and proceed to the next one. Okay. From the smallest to the what? From simplest to the what? The most complex. Alright, let's go. Yeah. So now look at this. Look at this. In. Double bond. In. So the name will end in double bond. The other one in. So let's number it. Let's number it. If I number here 1, 2, 3, 4, 5, 6. If I say here number 2, number 2 is carrying this substituent or attachment. Here number 5, all these ones they are not carrying this number. Let me say 1, 2, 3, 4, 5, 6. So if I number it 1, 2, 3, 4, 5, 6. No, this one is closer. This side is closer. This side is closer to this attachment. This one after number 1. This but this one is number 4 that is carrying it. So this side is closer. So we number it like this. Alright, let's go like this now. Alright, let's go. So look at this one will also make us understand it better. So now, see, number 2 is carrying it, number 3 is carrying it, number 4 is carrying this. So name it, you can. 2,3 dichloro, 2,3 dichloro, 4-methyl, 6 hex 2-ene, hex 2-ene. After number 2 is carrying this, 2-ene, hex 2-ene, 2-chloro, 2,3 dichloro, number 3 dichloro, 4-methyl, 1, 2, 3, 4, 5, 6 hex 2-ene. This is very simple, and you can do something better than this. Alright, I'm going to give you an assignment, but at the end of all the teaching today. So let's go like this. Okay, let's go. Now let's name this one. After naming this one, we enter the functional groups. So look at this. Let's number it. See, triple bond here. So now 1, 2, 3 before you have this. See, 1, 2, 3. See the first substituent or attachment. See, 1, 2. So now this one 1, 2, 3. 1, 2. So it's better to number from here. Can you see the difference now? So number it 1, 2, because this side is closer to this substituent or attachment. 1, 2, 3, 4, 5, 6, 7, 8. So it is oct. Now 3. So the name will end in "-ine", triple bond, "-ine", octine. So let's check it now. See, 2,2-dimethyl, 2,2-dimethyl. Then 2,2,3. It's not even just, it's 3. 1, 2, 3. 2,2,6-trimethyl. 2,2,6. 2,2,6 is tri, not di. So we have 2,2,6-trimethyl oct. 3-ene. 3-ene is 3 number 3 that is carrying it. 3-ine rather, sorry, triple bond. 2,2,6-trimethyl oct. 3-ine. This is for this very one. So you can see that we numbered from here to this way, not to this side, not right to left, because this side is closer than this one. 1, 2, 3. So if you see 1, 2, 3, see 3 here, with 1, 2 here. So it's better to number from here. Alright. So this is for this one. Now draw 2, 2, 4 trimethyl pentane. Nice isobutane. Isooctane. Alright, 2, 2, 4 trimethyl pentane. An isomer of octane. Alright. Okay. So we can now move to the functional groups. Now, what if you have something like this? Let me change some. Let me give you something like this. CH3, CH3. Now, okay, let me see. Okay, let's see like CH3, this one is CH2, CH3. So now look at it. When you have something like this now, look at something like this, it changes. This thing is not the same as the other one. So let's name it. Let's name this one. Let's name it. CH2 CH. So C. Alright. Let's look at this now. What is the longest carbon chain? It's not like this. It's not like this. The longest carbon chain is like this. So you number it. Now, where do we number from? We have 1, 2, 3 before you have this. We have 1, 2, 3 before you have this. So it's like the left side is balanced with the right side with what is attached. But we have 1, 2, 3, 4. We have this. So we have 1, 2, 3, 4, 5. We have this. Now, since this triple bond is here, it is going to now determine where to number from. So, but if you have a single bond here, like this, it means that you have to number from here like this. You have to number from 1, 2, 3. The number 3 is carrying this. 1, 2, 3 is carrying this. So you number, when it's balanced, you number from right to left. But look at it now. You have triple bond. This triple bond, you now start checking which side is closer to the triple bond in this situation, since it's almost balanced. It's almost balanced. This one is attached. 1, 2, 3 is carrying it. 1, 2, 3 is carrying it. So what of this triple bond? So this triple bond now determines. So now let's check. 1, 2, 3, 4 triple bond. 1, 2, 3, 4, 5 triple bond. So number from here like this. Did you get that? So it's another technical thing that we're looking at. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can name this. You can name this. This is, we have 1, 2, 3 attachments. So it is 3, 3, 7. This is 3, 3, 7 trimethyl nonane trimethyl non 4 non 4 ine. This is number 3. 3 is carrying this and this. These are attachments. So 3, 3, 7 trimethyl 1, 2, 3 non 4 ine triple bond. So that is for this one. So please, let's continue. Now let's look at the functional group. Is it bright? Okay. Now, what we have here are organic compounds with the functional groups. Different functional groups. We have the carboxylic, we have the alkanone, we have the alkanals. So we have different carboxylic, we have different functional groups. So a functional group is a radical, an atom or group of atoms common to homologous series, which determine the chemical properties. Functional group. Take note. The functional groups determine what? The chemical properties. While the alkyl groups, the alkyl or alkyl as you may pronounce it, determine what? Affect the physical properties. This physical what? Properties. This one affect chemical what? Properties. Alright. So let's look at the functional groups we have. So we start with the alkanol. Please, if you can pay good attention, serious attention, and follow this, you will be able to answer questions on this. You'll be able to draw it very, very well. It is not difficult. This ROH, this is alkyl, this is functional. ROH. So now this R, generally R represents CnH2n plus 1. This is this. CnH2n plus 1. So now if you want to get ethanol, that is C2, C2. So C2, you can draw it like this. 1, 2. Then OH. This is ethanol. 1, 2 OH. This all ethanol. So we can get our propanol. 1, 2, 3 OH. Like this. Propanol. This one is not difficult. This is not difficult. Now we can have something like this. 1, 2, 3 OH. So this put hydrogen here. Hydrogen. This is 1, 2, 3. This is propan. 1, 2, 3 triol. Propan. 1, 2, 3. 3 triol. 1, 2, 3 triol. 3 all. Propan. 1, 2, 3 triol. OH is for all. Alright, so you can draw butanol. 1, 2, 3, 4 all. Alright, so anywhere it is attached, 2, 3 methyl, dimethyl, any one at all, OH, just identify it. So let's continue. We may look at other ones under this. So be very conscious of that. Alkanol, ROH, alkanol. Alright, so Now we move to the next one. We move to the next one. After this, I will give you all of them one by one together as one. So we move to the next one. We move to the next one quickly, quickly. Alkanoic. Alkanoic. That is R-C-O-O-H. Oic. Oic. Now look at alkanol. Alkanol. All. Oic. 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 All. Look like that. It's not difficult. So we can draw it like this. R-C double bond O-O-H. So if you see something like this, it is oic. Oic. Example. Ethanoic. 1, 2, 1 OH. Ethanoic. Ethanoic. This is ethanoic. Propanoic. Okay. I don't want to make it complex now. I'm going to give you other ones that will make it complex. Propano. 1, 2, 3. Propanoic. Oic. So we'll move to the next one. I just want to run it before we now enter these ones that are something like this, something like this. So from simple to complex as we are taking it. So move to the next one. Let's go to the now there's something I think I forgot. See, this carbon atom is already there in the alkanoic. So it's already one. So if you have something like butanoic, you want to just write the molecular formula. But 1 is already there, so it remains how many? 3. But is 4. So 1 is already in the functional group. It remains how many? 3 to make it. So C3, H7, COOH. This is molecular formula. 3 plus 1, 4. 3 plus 1, 4. That is butanoic. This is molecular formula. Butanoic. Take note of that. 3 plus 1, 4. Butanoic. Take note of that. Thank you very much. I'm happy I did not forget this. Alright, let's go to the next one. Next one, the alkanoids. This one is technical alkanoids. That alkanoid, we call them the carboxylics. Carboxylic. 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 The alkanoids are called the esters. That is RCOOR. I call it alcohol. I call it alcohol. Just like alkanoids. Alkanoids is alcohol. Alkanoids is raw. That's what I call it personally. Mr. Primus calls it raw. Alcohol. Alkanoids, alcohol. For me to remember it. Alright, that was how I learned it. So that I would not forget. So now look at this. So now, see these asterisks. This means in naming, this one comes first. As well, you take note of this carbon atom that is already there. So in naming this side comes first. This side comes first. So if you have something like ethyl butanoids, this ethyl means that this is this. This R is ethyl. But this one is this. So this is this. This one stands for this. But 1 is already off. Remaining how many? But is 4, right? So 1 is already here. Remaining how many? 3. So this R will be C3. H 3 times 2, 6 plus 1, 7. Then COO, then enter ethyl. H is C2. H 2 times 2, 4 plus 1, 5. So this is ethyl 1 plus 3, 4. Butanoids. Ethyl butanoid. You draw this thing like this. R C O O R. So we can draw it like this. So 3 plus this one 4. 1, 2, 3, 4. Now O 1, 2. So you can link all of them like this. I just decided to be using it like this, not the condensed one. So look at it. Ethyl 1, 2, 3, 4. Ethyl butanoids. Ethyl butanoids. Alright, let me draw this one. You are going to name it for us and put it in the comment section. Let me draw this. You are going to name it and put in the comment section. Alright. So let me do it like this. So I will draw it. Draw it. C3H7. So name this one for us. Let me make it in the condensed form. CH3. This one is inside. CH2. 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 So name this. What is the name of this? C3H7. Then like this. Name it and put it in the comment section. So we are through with the alkanoids. So if I want to write this thing, I'll write it 1, 2, 3. So I have C, C4, H9, COO, C3, H7. What is this? What is this? What is this? Alright. What is this? What is this? Okay. So we have taken care of the alkanoids. Let's go to the alkanal. I call it archo. Look at it. I call it archo. Alkanal. Archo. CHO. Archo. Alkanol. Raw. Alkanoid. Alku. Alkanoid. Alkanoid. Alku. Alkanoids. Alku. That's what I call it. Mr. Primus calls it alku. Raw. Alku. Alku. Then alkanal. Archo. Alkanal. RCHO. So now this RCOH. If it's like this, it's alkanal. Alkanal. So this is already here. So it's almost like this alkanol. Like the same. I treated something like this in one of our naming of organic compounds, jam past questions and answers. So something like this. These two. Now, so what we are going to do is now. So let's draw butanal. We are going to see something like this is here. We have to see it. See, this is the difficult one. So from simple to complex, we are going to name this. So continue following us. We are going to name that because that's CHO. See it here. Alright. So now butanal. Butanal. 1, 2, 3, 4. So butanal. There's already one C. But so you have C3H7 CHO. This is 3 plus 1, 4, butanal. So OH, this is butanal. Link them. You can have pentanal. 1, 2, 3, 4, 5. OH. This 1, 2, 3, 4, 5. This one is pentanal. Pentanal, butanal, pentanal. So this one is already taken care of. Keep following us. Please subscribe if you have not subscribed. Remember to share this as I've been requesting. Like this video. Make comments. Ask questions. Whatever we are not doing well, we are free to still say, I thought you would have done it like this or like that. Then it will help us to do it better next time or even repeat this. Thank you very much. Thank you as we are all learning. Alright, let's continue like this. So we'll continue with this one, the alkanone. I call it alcohol. So let's revise. You know what we have been doing? This one is alkanol. This one is alkanoic. This one is alkanoids. This one is alkanal. We are now in what? Alkanone. Alkanone or alkanon as it may be pronounced. So now this is RCOR. This one is CH3. So if you have this RCOR or like this R can be like this or like this R as it may be. So now we take it like RCOR. It's the same thing. So now we have propanone. 1, 2 CH3. This is propanone. That is C3. 1, 2, 3. Propanone. This is RCOR. So if you have pentanone, 5. Pentanone, you can write it C3H7 COCH3. 3, 4, 5. 3 plus 1, 4 plus 1, 5. Pentanone. So C 1, 2, 3, 4, then 5. Pentanone. We have something like that here as well. Alright, see it. This one is an alkanol. This is an alkanol. This is an alkanol. This one has carboxylic, alkanoic, alkanol. This is a combination of two. Alright. So we continue. We have done alkanol. So we may go to the amine. The amine and amide. Amine. The amine is RNH2. That is RNH2. So if you have ethanamide or methanamide, C2H5NH2. If it's methanamide, CH3NH2. That is C12, something like this. This one is methanamide. But what we are talking about is what? Ethanamide, 1, 2, NH2. Ethanamide, eth, C2. You can have propanamide, butanamide, pentanamide, C5, H11, NH2. Pentanamide, pentanamide. So we can do other ones under this, the amides, and let's go to the amines. Am I too fast? I don't know. I think I am not too fast, but we are working with time, so I don't want to waste our time. So now go to the amide. Now watch. Amine. Mr. Primus calls it alcone. Amide. That is RCONH2. The amide. So you can have ethanamide or butanamide or pentanamide, C3H7CONH2. But butanamide, C5H7CONH2. 6. That is what? Hexanamide, 5 plus this one. C5H11, 5 times 2, 10 plus 1. C5H11. So this one is what? Hexanamide, 6, 5 plus 1, 6. Hexanamide, you can draw it in this form. 1, 2, 3, 4, 5, 6, ONH2. Hexanamide. So this is hexanamide. So now let's make a full recap of those functional groups I pointed out now. In the first one, alkanol, I guess, R what? Alkanol is R what? Okay, very good. ROH. Now, alkanoic, that is the carboxylics. RCOOH. The alkanates, IUPAC, ester, is what? Alcohol. RCOOR. You know what this thing means? I've explained it. Now the alkanal is what? RCHO. Now the alkanon is what? RCOR. Right? Then I think I forgot alkoxy. Alkoxy is ROR. Like something like methoxy, methane. Met, CH3OCH3. Methoxymethane. You can also have C2H5 OC3H7. Oxypropane. Eth is to ethoxypropane. So these are alkoxy, ROR. Okay. So now I have the amine, RNH2, and the amide, RCONH2. So this is what you need to memorize. If you can memorize all these, then we may still have another class where we bring many other organic compounds and name them, and some other ones I will write on the board and ask you to draw. So what matters is to name and also be able to draw. But if you can name, you can equally draw. Thank you very much. So let's look at this. Before that, I would like you to do this. Right. Okay, let's name all these now very quickly, having learned all these. So look at this. First of all, Which functional group is present here? CHO. This is single bond. So, but because there is functional group supersedes every other thing. Be it a substituent like chlorine, bromine, or the alkyl, anything at all, or even double bond, the functional group is more powerful than any other one. Take note of that. So now, this is CHO. The functional group here is CHO. See it? CHO. So the name will end in al. Anything we are doing, al. That is the name, not N. If there is no functional group, it will end in N. Alkane, single bond. But because of this functional group, you have al. Now let's number it. Which side is closer or to the functional group? See, 1, 2, 3 here. But we have 1, 2, 3, 4 here. No. So we'll number it from here. So this is 1, 2, 3, 4, 5, 6. So 6 is hex. Hex. So it's hex something al. Now see, 3 al. Hex 6, hex 3 al. So I can even put 3 hex 3 al. Now let's look at this one. How can now hex 3 null. Now hex 3 null. Oh yeah. Hex 3 null. Oh yeah. Let's look at this one now. 4 methyl. 4 methyl. Hex 3 null. So it's 4 methyl. 4 methyl hex 3 null. Because it's number 4 methyl hex 3 null. So that is for this very one. Hex 1, 2, 3, 4, 5, 6. Methyl hex 3 null. Alright, so let's look at this one. What is the functional group here? The functional group that is here. What is the functional group? Okay, we have OH. We have O. C double bond. 1, 2 double bond. 1 OH. So number it from here. Not here. Can you see the difference now? This one we have 1, 2, 3 here. We have 1, 2, 3, 4 here. So number it from here. Like this. But this one have 1, 2 double bond. Before you get to this point, but 1, see it. 1, 2, see it, see it. So this one, now, which one has double bond OR? OR, RCOR. This RCO, RCOR, RCOR. Where is it? Alkanon, RCOR. So the name will end in what? N-O-N-E. N-O-N-E. So number it from here. 1, 2, 3, 4, 5. So 2 O, 2 none. Look at it. 2. Number 2, put it like this. Right, let's check it. Oh yeah. 1 hydroxy. See, 1 hydroxy. So it's 1 hydroxy. 1, 2, 3. Pent 3 in 2 O. 1, 2, 3, 4, 5. Pent 3 in 2 O. Very good. 1 hydroxy. 1, 2, 3, 4, 5. Pent 3 in 2 O. So 1 hydroxy. 1, 2, 3, 4, 5. Pent 3 in 2 O. That's for this one. Very good. So let's name this last one now. This last one for today. Alright. So now we have OOH, OOH. This is carboxy. Carboxy. This is all. So now I have 1, 2, this. 1, 2, this is at the center. So number it from here. 1, 2, 3, 4, 5. So it's 3 carboxy because this is hydroxy carboxy. Hydroxy carboxy. C. Carboxy hydroxy. So this, in alphabetical order, this one comes first. So it should be what? 3 carboxy. 3 hydroxy. Oh yeah. 1, 2, 3, 4, 5. Oic, OOH. See it. Oic, OOH. 3 carboxy, 3 hydroxy, 5 is pentanoic acid. Very good.
pentanoic acid, 3 carboxy, 3 hydroxy pentanoic acid. That is for this very one. So alright, let me give you assignment, the ones you have to draw. You can send it to me. Check all other lesson videos we have. I put my phone numbers there. Alright, thank you very much. So have your assignment now. Alright, this is your assignment. Name this organic compound. Name it. And if you name it, put your answer in the comment section. Or for those of you that have my contact, you can send it to me on WhatsApp. Alright.